Good morning, class. Okay, so you guys had some homework yesterday, correct? Yes. There was a few sums that you had to classify in which category it falls. Not so. In terms of rational, irrational, real, non-real. No. Integers, whole numbers, natural numbers, rational and irrational. Okay. Non-real and those things you learn in the higher grade. Okay. So these were the sums that or the numbers that I asked you to classify. So 8 recurring. Is that natural? No. Is it whole numbers?
No.
Is it integer? No. Is it rational?
Yes.
Is it irrational?
No.
Now 2 and 1/6. Is it natural?
No.
Whole?
No.
Integer?
No.
Rational?
Yes.
Irrational?
No.
Pi. Is pi natural?
No.
Come closer. No. Is it whole?
No.
Is it an integer?
No.
Is it rational?
No.
Irrational?
Yes.
Yes. Negative square root 3. Now, if the negative was not there, is square root 3 a perfect square?
No.
No, it would have been irrational. Now, negative root 3, is that irrational? Yes. The square root of negative 3, however, that is non-real. That doesn't exist to us. Not so. But negative root 3, that is irrational. 2, is that natural? Yes. Whole?
Yes.
Integer?
Yes.
Rational?
Yes.
Irrational?
No.
Square root of 16 over 25 is 4 over 5. So we did judging on 4 over 5. Is 4 over 5 natural?
No.
No. Whole?
No.
And integer?
No.
No. Rational?
Yes.
Irrational?
No.
The next one is 1,35 recurring. Is 1,35 natural?
No.
Whole numbers?
No.
Integer? Rational? Irrational? And the last one 0,75. So this is a terminating decimal number. Is that natural? Is it a whole? Is it an integer? Is it a rational number? Yes. Is it irrational?
No.
Is there any confusion regarding these categories of these numbers? Okay. Yes?
Why is 8 over 8 recurring a
Which question?
the first one?
0,8 recurring. Because that number 0,8 recurring can be written as a fraction. Sorry? I'm going to show you in today's lesson. We'll show you how to write recurring numbers as fractions. We're going to do that now. Okay. Any other confusion? No? So your heading for today is recurring decimal fractions to common fractions. That's your new heading. Okay, so we are writing recurring decimal fractions into common fractions. Okay? So this is example on page 2. So there's a process that this number goes through to land up into a fraction. Okay? So what we do is we say, okay, we let this recurring number, which is 0,6 recurring, be x. So we say let x equals 0,6666666. You all agree that that number has sixes all the way to infinity. Not so? It's all the way to infinity. So we ask ourselves, okay, how many numbers are recurring? Or how many numbers are recurring? How many digits are actually being repeated? Different digits. 1. There's one digit that gets repeated all the time. Not so. And this number is what in this case? 6. There's one number that's being recurred. So since there's one number that's being recurred, I multiply this line, this equation, by 10. Okay? Later on you'll see these two numbers recurring, what's going to happen. So you multiply it by 10. If you multiply this by 10, what's x times 10? 10x. So what is 0,6666666 multiplied by 10? 10. Yes. No, the other way around. That's when you divide by 10. 6 comma. If I multiply this by 10, what's going to happen to the comma? It's going to move 1 unit over. 6666666. Not so. And so on. You all understand? So what I do now is I rule a line here. And what I do now is I subtract those two lines, those two equations. What is 10? So I multiply this by negative now. No? What is x minus 10x? Negative 9x. So what is 0,66666 and it carries on minus 6,66666? What will happen here? That will cancel. Not so. And that's what we want. We will try to eliminate the recurring number. Okay? So what's 0 minus 6? What's 0 minus 6? Negative 6. Okay? Don't touch my stuff. So you're going to get negative 6. So how do I get x on its own? You divide both sides by negative 9. So you want x on its own, not so. So x is equal to negative cancels negative. So 3 goes into 6 twice. So it's 2/3. Okay. And we can test it. You say 2/3. You guys understand? So take this down, we'll do another sum now. Sorry? If it's more than if it's 2 numbers recurring, you multiply by 100. If it's 3 numbers recurring, multiply by 1000. You understand?
Depends on how many
Numbers are recurring, it's absolutely. Okay. Let's look at the next question. This is example 2 on page 2. So the question now is to write 0,45 recurring. The 4 is recurring and the 5 is recurring. Right. So where do we start? As we started before. We say let x equal 0,45. 45. 45. You all understand? Now what do we do? You multiply it by 100. Multiply this line by 100. By multiplying this by 100, it becomes 100x equals. So how many digits is this formula going to move by? 2 digits. Not so. And these 2 numbers recurring, that's why it's 100. Say for argument's sake you got 0,1, 2, 3. 1 is recurring, 2 is recurring, and 3 is recurring. Then that, in the second step, you'll multiply that number by 1,000. Why? Because they want to move the comma 3 units. You guys understand? Okay. So by multiplying this by 100, we'll get now 45, 45, 45, 45. What do I do thereafter? Subtract. Okay. So subtract. So it's going to be x minus 100x. X minus 100x gives us negative 99x equals. So 0,454545 minus. So what's going to happen here? It's going to cancel the recurring part. Not so? You guys understand? So now it's going to read 0 minus 45. Okay. So how do I get x on his own? Sorry? Negative 99 both sides. That cancels, so x is equal to negative divided by negative is positive. Okay? Then 9 goes into 45 5 times, 9 goes into 99, 11 times. Okay? So it's going to be 5 over, and we can test it again. 5 over 11, 0,454. Does it make sense? Still not? Well, which part don't you understand, Michael?
Your attention please, grade 12A and B, can you please make a way to the hall? For those learners who haven't reported to the hall yet, can you please make your way to the hall? Grade 12A and B only.
Yes, Michael? You see, the idea is to minus this line here on the second line. Why do we do that? So that we can cancel this recurring point. So that we can get rid of it. You understand? So when we multiply, like here was 2 numbers recurring. When I multiply this by 2 and the digits move to units. Then what do you notice? What is after the comma? The same thing. So if I minus 1 minus 1, what's 1 minus 1? 0. What's 0 comma 2 minus 0 comma 2? 0. What is 1 comma 627 minus 1 0 comma 627? What's going to happen is that must cancel. Can you see that? So this idea I've implemented here. Okay, by doing that, this cancels that. Then it leaves us with the whole numbers only. That's the idea. Okay, yes?
So I'm keeping negative 45.
0 minus 0 minus 45 is negative 45.
So you say x minus 100.
There we go, yes. X minus 100 or 1x minus 100. Anything else? Any other confusion, people? Let's do another one. The third example on page 2. Not deleted for some reason. Alright, so where do we start in number 3? Let x, yes? Let x equal, sorry, 2 comma 18, 18, 18 and so on. Now what? Times it by 100. Why 100? 2 digits are recurring. You all understand? So that will be 100x is equal to 2, 18, comma 18, 18, 18. That carries on. So what do we do now? Subtract the 2. So let's subtract. So what is x minus 100x? Negative 99x equals. What happens here? Cancel. So what's 2 minus 218? Negative 260. Now what? Divided by negative 99 both sides. That cancels. So x is equal to 216 over 99. I think 3 goes into 216. Yes. Looks like 3 goes in. Let me just check. 3 goes into 21. Yeah, 3 goes. 3 goes into 21, 7 and in 6, 2. So 72. 3 goes into 99. 33 times. Not so. But I think 3 goes into 72 as well. So 3 goes into 72, 3 goes into 7 twice, carry 1. 3 goes into 12, 4. So 3 goes into 24, 74. 3 goes into 72, 24 times. The 3 goes into 33, 11 times. So the answer is 24 over 11. Or, I can write it in mixed fraction form. Both will be acceptable. 11 goes into 24 how many times? Twice. And how much remainder? 3 over 11. And we can check if we're correct. There's a mixed fraction 2 and 3 over 11. Nope, it's not correct. It's 22 years, it's 2 remaining. Okay, sorry about that. Here we go, 2,18181. Does it make sense, people? Okay. So for homework, I want you guys to do from the exercise on page 7. I want you guys to do number 5. On the exercise, that exercise on page 7, you do number 5, the odd numbers. Okay. That's on page 7. Who's taking the homework, Jada? Then something else I want you guys just to bring your attention to. The next heading is irrational numbers on the number line. Irrational numbers on the number line. Right, now remember we spoke about irrational numbers. Not so. We said that irrational numbers are numbers that cannot be written as fractions, does not terminate and does not recur. Those are what irrational numbers are. Okay? Now irrational numbers, if we must now represent that on a number line. Let's take the square root of 5 for argument's sake. And they ask you to represent that on the number line. The question you should be asking yourself, what is the largest... Are you moving this book around? What's happening? You see your diary. But aren't you in the class group? So the homework comes in the group. So you're reading your choosy stories. People, you should be asking yourself, what is the largest perfect square less than the square root of 5? Firstly, what are perfect squares? Square root of 1, square root of 4, square root of 9, the square root of 16, the square root of 25, and so on. Those are perfect squares. So what is the largest perfect square less than 4? Less than 5? 4. And give me the answer. And what is the smallest perfect square? Greater than 5. Greater than the root of 5. Greater than 5. Can you see that? So in other words, it's going to be 2 and 3. We put that on a number line. 2 and 3, and that's going to be the square root of 1. Easy enough? And I take that one down, and then you guys do one of your own. You don't waste your time. Guys finish? Okay, so the question is, what is a perfect square? The largest perfect square less than the square root of 11? It is square root of 9. The smallest perfect square greater than 11? Root of 16. In other words, this would be the square root of 9? Square root of 16? 4. So the square root of 11 lies somewhere between 3. Makes sense? Can you do one more? Then we can move on. Okay. We'll use this as a third example. The square root of 45. Guys finish? No. Struggling. So what is different? So you struggle with all three sums, so with the previous two as well. No. So what is different with the sum opposed to the sums that we dealt with before? So you just carry on. What's the next number? The root of 36 is 6. The root of 49 is 7. Should I have written all the square roots? Right. For those of you who are confused, your confusion comes in here. The square root of 36 is the next one. Square root of 49. The square root of 100. 10. The square root of 64. 8. Square root of 81. And so on and so on. I can't give you everything. So, what is the largest perfect square less than 45? 36. The square root of 36. And the smallest perfect square greater than 45? 49. Square root of 36 is 6? 7. The square root of 45 lies between it. You all agree with that? What if I had asked you as an example for the cube root of 10? Then what? Then we will need to look at perfect cube roots. Yes. And what are the perfect cube roots? Who can tell me? Yes, where the first one is the cube root of 1. The cube root of 8. So 3 is the cube root of what? 27. 6 is the cube root of what? And 64 is 4. 216. 216 is good. So that is 36 times 6. Is 36? 18. Yeah, 216 is good. So what is the smallest perfect square? Oh, sorry, the largest perfect square less than root 10? Root 8. The cube root of 8. Larger than 10? The cube root of 27. So in other words, the cube root of 8 is 2. The cube root of 27 is 3. So the cube root of 10 lies between. You understand? What don't you understand? Do you understand the previous 3? So the difference between number 4 and the previous 3 is, here we're speaking about cubes and cube roots. You see, what is 1 cubed? 1. 2 cubed? 8. 4. 3 cubed? 27. 4 cubed? 64. 5 cubed? 125, and so on. So what is the cube root of 1? 1. What's the cube root of 8? 2. What's the cube root of 27? You understand, Michael? So the question you should be asking yourself, what is the perfect cube, the largest perfect cube greater than, and less than, sorry, the cube root of 10 is the cube root of 8. And the smallest perfect cube greater than the cube root of 10 is the cube root of 26. You understand? Okay. Any other confusion here? No? For homework, I want you guys to do out of exercise, that exercise. You're going to do for me number 3 on page 6. Number 3 on page 6. Okay. Any confusion, people? No. Okay. So that brings us basically to the end of the chapter on the number systems. Okay. Real numbers. Okay. So your next heading is polynomials.